More than well. Hello, my name is Aleksandar Jelenak. I'm working at HDF Group, and this is my Tuesday of the month to talk about stuff that are at least somewhat related to HDF. And so we shall begin. Oh yes, sharing screen. So I usually mention. Oh, that's the one. I didn't kill this one. I think that's one I want to share. I usually open up with some overview. Okay, how will I get rid of this? All right, so I open up with H5Pi. I tend to contribute to H5Pi from time to time. I don't consider myself maintainer because then you have to respond to people's questions. And I prefer to duck on that responsibility more often than not. So basically, but the interesting couple of things, maybe to go over. One, for example, recently there was an idea that the new fast chunk iteration method in HDF5 library be more visibly included in the high-level H5Pi interface API. So right now it exists at the low level. I'm perfectly happy to use it as is because I know that it's there. I put it in. But typically people who use H5Pi, they don't go all the way to that level when they want to use H5Pi. So there was this idea to enter it. Unfortunately, not fortunate, but there is one problem. We already have something that talks about chunk iteration in H5Pi, which is for different reasons. And so we have this name clash on the high level where to put it. So we'll see where it goes. I usually stand away from these discussions mostly because I think it's up to the H5Pi community and their users to decide how they want to do it. But as already mentioned, I know that it's there in the low level and I'm perfectly happy to continue use it. And by the way, it's really tremendously faster. If anyone is interested in finding file locations of dataset chunks in HDF5 files, this is really the method to use. The old ones are just very much slower. So that's that. And of course, if anyone has any questions, wants to comment something, correct me something, just talk, don't wait. And I probably won't see the raised hand, so just keep going. The other thing that's kind of interesting is, I think, this one, because that's kind of the lead-in for today's main part of my session call. This is when I heard about the Anndata Python package, but this is the case that came from a user of Anndata Python package, and they had a problem trying to store Anndata into HDF5 file using H5Pi, and Anndata package allows essentially coming to the HDF5 level, allows integers or floats to be the keys of HDF5 attributes. And that's a no-go for HDF5 library. And so this is the time when I kind of first seen some issue with Anndata package trying to serialize or encode its data in HDF5. And that's why I decided to take a look and a bit more about Anndata package. But this is the one, I don't think this is resolved. It's labeled as a nice first issue, for example, for someone to actually change H5Pi and throw a more meaningful exception than the current one, which is basically this one, float object has no attribute in code, which is kind of like what? And so effectively, this would probably be some kind of a text that says you cannot, only strings are allowed as HDF5 attributes, or at least any object that can be translated to some byte. Or something like that. But generally speaking, they tried directly to store it as integers and floats, and that went all the way down to the HDF5 library, and it didn't go well. So, so that is that. And here comes another pull request. I think it's kind of relevant for people who are more into HPC. I'm not. And this is this subfiling PR. It's been going on for quite some time. subfiling is a new feature in the HDF5 library 1.14.0. And don't trust what I'm going to say, but please someone correct me if I'm wrong. Subfiling basically allows people in HPC computing to create multiple HDF5 files that are basically parts of one HDF5 file. In other words, it's kind of sharding of HDF5 file concept, but not going all the way like some other cloud native data format. Yes, so the support for generally for HDF5 library 1.14.0 has been, it's available in H5Py 3.8.0. However, the subfiling part is not something that's still there, and this is a long time going TR, and the person I think who is doing this is in Czech Republic. But although he kind of got right the H5Py part of things, and how to go all the way and interface with HDF5 library with this feature, I think he's now more into the typical HPC kind of issues, which is optimization and performance. And so I don't know to what point this will eventually make it into H5Py. I think at some point probably it's worthwhile to say, let's have the feature in and then worry about performance later. Those two things can be different, but we'll see how it goes. But anyway, if anyone who is interested in HPC and this kind of subfiling feature is interested, I think, and wants to use all those from Python, that probably this is some PR that you should pay attention to and maybe try to jump in and contribute to the discussion. So I don't know right now where this is all going in terms of making it into H5Py. The good part is that some of the HDF staff is now involved, which is a good thing. I just don't know, again, where it's going to end up. Anyway, so that's pretty much about H5Py. Unless there are any questions or something that I forgot to mention and people like, I should move to the real part of this call. No, okay. So it's Anndata Python package, or Anndata or annotated data for sure. So I'm not going to read what it says here, but I wanted to talk and mention this package in the context of HDF5 file content interoperability, because the way I see it, there are different levels of data interoperability, and what I call the fundamental interoperability is where you have essentially little endian versus big endian, so to speak, so that you can bring files created on a big endian machine, on a little endian machine, and it's possible to read it and does that kind of thing. Or you have created files, let's say, on some kind of HPC system, and then you bring that file out of that system, and again, it's able to be read and successfully data accessed. So that's fundamental interoperability. The next level to me of file content interoperability is that you actually look into the content of those files and say, okay, are the data in those files organized in some way that makes sense and it's usable by many programming languages, or there are many software that support that kind of organization, or then there is only one software in a particular programming language that actually can access data in this content. And for example, one of those cases is Pandas Python package for tabular data. If you choose to export Pandas data frame, which is a table, into HDF5, the type of HDF file Pandas created is pretty obscure, pretty opaque in terms of where is what. And if you would basically give that to someone else, some other programming language, take it out of that, it would take an effort for someone to write a reader and actually recreate the table and on those tabular data in some other software, for example. So that's not really interoperable. That's more on the level of a particular software accessing file content, which basically means don't worry how things are organized in HDF5 file. Here's my piece of software. It'll read and write you don't have to worry about anything else. I think this kind of level of interoperability is also applicable to a lot of software which puts performance as the highest priority, so that the way how they store data in HDF5 is really, really tuned as much as possible for performance. Again, those files may not be really usable in many other programming languages because you have to write a lot of specific code to get the data out. The level of interoperability that I want to use this package to say, it's kind of in the middle, which means that it's not just on the lowest level of sort of hardware of little endian, big endian, or you have this compression method and or that compressor plugin and that kind of thing. It's really trying to find that middle ground that the content is reasonable enough, easy to explain and understand. And so it is possible to make readers and writers in many other programming languages and achieve the goal that the data really is truly interoperable still. And what I'm talking about, I'll just illustrate that. I'll go to this section. Oh, they actually have interoperability, but I want to come here. So they talk about on this format. What basically means that they have elements, different data objects in Anndata package. And then they're talking how to store them in HDF5 and also ZAR. And sorry, excuse me. And ZAR is this new cloud native data format that I don't know about other communities, but it's really gaining huge popularity in geoscience. And so, so they already have essentially something that says, okay, if we want on disk or on a file system, we're going to use HDF5 file. We want cloud, we're going to do it in ZAR. And so although those two decisions are already making choices for them how they want to be interoperable, because what may be possible in HDF5 may not be exactly possible in ZAR. But we'll maybe discuss it later. At this level, they have these data structures, data objects, data types, call them how you will, that are on the level of Anndata package. And they're now talking about them, how to store them, and they define the ways how they want to do it in HDF5 files, for example. And since I mentioned pandas, and since I mentioned tabular data, let's go to data frames. That's the name that means tabular data. And so what they define and implement here is essentially a columnar format for tabular data, which is very interesting because in HDF5, traditionally, people store tabular data using compound data type. And the reason why they used that was because the HDF5 library did all the work. Basically, you could use the HDF5 library on the lowest level of its API, when I say lowest level, at the most direct level way. In other words, you would define a one-dimensional HDF5 data set with compound data type. Every element of that data set was a row in the table, and the fields of that compound data type were columns. And as soon as you say, I want this, a slicing operation in one-dimensional data set, you get all the rows with all the columns. And so that was super easy, very easily mapped into the basic HDF5 access operation. However, with the rise of big data, tabular data, and all the other ways to store them and process them, Hadoop and now cloud, there was now need in recognizing that actually it helps when not all columns are kind of tightly grouped together into rows. It actually helps when the columns are kind of their own each entity. And Anndata basically adopt this approach, and they define that every column is going to be a separate HDF5 data. And why I like this is because in several projects that I worked on, this was actually a better way to store tabular data in HDF5. However, on the HDF5 library level, there is no anything as easy to use as when you're storing tabular data using compound data type. And so I like this approach of columnar data type, and to cut story short, I would really like if HDF Group did make a step forward and actually decide to go a little above just fundamental storage operations using HDF5 library and define these kind of conventions so that people probably assume that, yeah, there is some best practice here. And there are some good things that, you know, are obviously in this kind of organizing the data, with the benefit that eventually many more programming languages are going to adopt this approach, and hopefully the data stored in this way does not require everyone to write their own reader to deal with this thing. So that's what I call the file content interoperability. It gets a little above purely fundamental HDF5 operations, but it's still not too much involving and too specific to any specific domain. So people say, it's too much for me. You know, I want to go my own way. Of course, anyone can do whatever they want. HDF5 library accepts many things. And if HDF5 library doesn't object, it does not mean that that also is a best practice.
But Aleksandar, isn't there an HDF5 table specification? It's not column-based, but I believe.
Yes, it is. Yes, it's here.
Okay. But so what you're advocating for is doing more of this, or maybe a column version based of this?
Yes, yes. That's my, yes. And with that, we can close up my my talk because that's the main point.
Yes.
But yes.
Mm-hmm. And I agree with Aleksandar and also, what Mark was pointing out. I think that was the original extension, the original intent of these things that we call high-level libraries. Unfortunately, they are also a textbook case in, let's say, not so great execution, in the sense that they were created as, and probably Elena has much more to say about that, they were created sort of not with the intent of serving, I mean, pick whatever quality metric you want, performance, code quality, whatever. They were not developed at that level, and but as a vehicle to implement patterns, as Aleksandar said, I think, yeah, let's do more of this. Well, let's first pay our debt and sort of try, to the degree that that's possible, correct some of these sins of the past, so to speak. And because, yeah, that's what users care about. Users don't care about, I mean, subfiling is a great feature for people who work in HPC and so forth, but the percentage of people that cares about subfiling is minuscule on the scale of the HDF community. That doesn't make it a bad feature or not something that we shouldn't do. We should do it, but we also have to keep in mind that what do 80% of the community in their day-to-day life care about in solving problems? And that's where the high-level extensions are. And yeah, we just have to invest more and show that. And I think this time it's also important, again, for starters, yeah, fix our own mistakes, but then in the long run also try to mobilize the community around this, because, yeah, we are in a bad position when it comes to sort of call it congealing these patterns, where, yeah, people who work with specific applications in certain domains, they have a much better sense of these patterns. I mean, do we on projects pick things up here and there and might say, yeah, there is probably a pattern here? Sure, but at the end of the day, the measure is always, how useful is this for 80% plus of the community? And yeah, that's where we should put our money and our effort.
You know, it's not clear to me always when it makes sense to have a high-level library versus when it makes sense to add more functionality to the core HDF5. For example, like virtual data sets. That's not a high-level library built on top of the core library. That was changes made to the core to support this paradigm of virtual data sets.
Right.
Yeah.
So usually conventions, if you're talking about conventions, the easiest way is to create high-level library, right? Like we have HDF EOS or the stable or dimension scales. But one can put it in the file format, and there were a lot of discussions where should it go. And for example, it is very reasonable to introduce an HDF5 sparse storage, column storage, different types of storages, and then do it transparently. Then people will be able to use that standard storage to represent in memory whatever they need. That can be, you know, read into those structures. So I'm not sure. And when, you know, not defending the quality of the code of high-level libraries, which could be better, it's hard to say. Some people complain, some people use them successfully. So I would not just disregard them. It's really, we need to talk, and different pieces of community will have different requirements. So it is really not as easy as presented like black and white. There's too much gray here. And I would say both approaches of high level that represent some conventions and enhanced storage mechanism in HDF5 that are transparent and portable are valid.
Right. I mean, is there anything to consider like pandas when they were deciding how they would utilize HDF5? Did they consider the table high-level library and found it wanting? Or
No,
were,
they wanted column storage, John. That's what because this is how they access it.
Yeah, that's what I'm getting at. You know, so in pandas, they want the ability to dynamically add additional columns, or to have columns where not the entire height of the column is actually allocated. And you can't get that just by using compound data types.
Yeah, and also, John, I mean, your earlier comment on, well, what belongs into the core library or sort of the low-level thing versus a higher-level extension, it depends. It's case by case. So virtual data sets, for example, is a good example in the sense, well, first of all, it's a misnomer because there's only one kind of data set in HDF5, and it's really a new storage layout. That's what it is. Like there is compact and chunked and all the rest of it. Virtual is just another storage layout. So it definitely belongs in the low-level library. Unfortunately, though, it is not as simple. And it's really a case by case. But then, of course, as far as cost in terms of maintenance cost, because that's the real cost, goes, yeah, we want to keep an eye on that and sort of err on the cost side in the sense, I would rather not have something in the core library if it can be implemented in a high-level extension and keep the cost or reduce the cost of the core library versus putting something in the library, because as we all know, and Elena knows best, once it's in the library, we can never take it out. It's there forever.
Well, but you're pushing this get to maintenance of high-level library, right? So there's no free cheese, you know.
Yeah, but in a way, to modify these higher-level extensions is cheaper than, because typically the amount of code that goes in there is minuscule compared to what's in the core library. But then, of course, I mean, one obvious way where the high-level extensions that exist from our side fall short is clearly that, sure, the core library can be at least compiled with thread safety enabled. However, all these high-level extensions are not thread safe. And making, so a first step other than cleaning them up would be also to at least add thread safety to them, But that, of course, yeah, requires a much closer integration with the library, where other than that, it just means re-implementing some kind of mutex or something, which would be kludgy at the high-level library level.
Mm-hmm.
Well, to come back to these things about is it worthwhile or not having this kind of simple conventions, or I mean even high level, that to me is a little misleading. But I think I would say after we're now going to celebrate 25 years of HDF5. I would say we don't have enough data that say that if this happened much earlier, I'm pretty sure based on other libraries, data IO libraries that did a little bit more in that direction much earlier, I think that there would be definitely a benefit. Now, after 25 years, yes, it's very questionable whether or not to do it. But again, as I say, where is the right amount of interoperability in a file content, in other words? You know, big endian, little endian, that sounds to me too much as, 20th century problem. To me, I think you want to go further up. There has to be something bigger than that, more substantial than just that. And then there is a question of where do you find the right measure? I think that now in our project, we've seen a need to have something that essentially is a columnar table storage in HDF5. These guys came up with the same problem, and they have essentially same idea that we have. To me, there are now data points that point out that this is possible, and that there is something to it. Not to mention, I completely, sparse arrays. That's another one, because fundamentally it comes down to,
we're designing them. You will get RFC soon.
Well, okay, all right. But again, it's where do you do this capability? That on top of HDF5 library, or you actually built in as something as storage layout or something like that.
The power of something like a layout, like a column or storage layout, is that it's one parameter that you throw out when you create the data set, and you keep the entire API, right? It's not like you're learning a new high-level API to deal with column or data sets.
Right. That's what I'm discovering with introducing sparse storage, that really there is no need for new APIs, and you can preserve compression and be even more clever. And those sparse design leads also to variable length new design that will be applicable and with compression. So for fundamental storage properties like column and sparse, I would advocate for library, while other conventions to be discussed.
Well, I didn't, since this is sort of not internal discussion, I would say, but let's say if I'm a user, when and what needs to happen before you have that feature in HDF5 library?
And that's
it's like, is this something that's going to happen in a reasonable amount of time, or it's going to happen? We don't know yet, but we're hopeful.
Right, and this leads to a bigger issue: how you involve community, right, and how you involve community in development of fundamental features. Because
I think that's another point. I think you can get more community. Sorry.
Right, small group cannot do it. And what we were missing during all those 25 years, there was really very hard to get input from community that represent HDF5 ecosystem. For example, pandas, I don't remember, we worked with pandas in the past only when they had some problem discovered, because HDF5 worked so well for initial developers that everything was fine, and it became really stable software adopted by big chunk of the ecosystem community. So how you know what is going on this HDF5 universe that represent high level approaches to storing that use HDF5 as storage format, right? And this is a big question, because if you know those requests, something can be done, funding could be searched for, but we do not have access to this information. So there should be some resource to help together this and had better feedback from the community, from wide community.
Yeah, but if you don't have, it's a question of, do you, again, I think at some point you have to draw the line and says, we're not going to seek anything anymore just because we cannot get any call. You know, you have to, everything that's been done has to be, we'll try next 6 months. After that 6 months, if nothing happens, we have to make a decision rather than you'll never address the problem. Or that's not the problem, an issue.
And it may be addressed because of community, not HDF group, right?
Mm-hmm.
Like,
well, that's why they have called the doctors. Hopefully people will jump out of nowhere and say, yeah, I'm dying for this thing.
Sparse storage we are designing, it will go into, suggestion is, it will be part of open source. It goes back to HDF5, but it is designed the way that it can be supported, it reuses the code, etc. And that's why HDF Group is involved, we're involved. So it's an example how community can work together. So not everything should be developed by the HDF Group.
Mm-hmm. Yeah, I want to come back to Mark. Mark had a question / a comment. How does this relate to the Parquet file format? Well, my response would be sort of, can you do what Parquet does in HDF5? Yes, absolutely. Does it look like Parquet? Is there an API in HDF5 that makes this look friendly? No, there isn't. So, I mean, I think it focuses for obviously use case reasons on call it incremental columnar layout, in the sense that you can combine columnar layout with incremental decompression, for example, and in-memory representation. And the answer is these guys did a great job in doing that, no question about it. Now, should, again, at a storage level, using combinations of data sets, can you do the same thing in HDF5? Yes, absolutely. But then again, if you, where sort of they call it the sticker shock, when people would open an HDF5 file that would emulate this, would be the same when, as Aleksandar described earlier, when a pandas generated HDF, which is a PyTables file, when you open the PyTables file, sort of unsuspecting users will ask, where are the tables? Because it doesn't look like what they would intuitively expect. And so it points in the same direction. But I had sort of more of a philosophical, since it's 25 years, hey, we have the luxury that we can reflect on HDF history. I think it's sort of like you see in many things, this pendulum between where does something belong. You can do that centralization versus decentralization. But if you look at the evolution of HDF5, especially the early versions, they were graphics formats. That's how HDF started. However, if you look at HDF4, what people saw was, well, we need more than raster images or something that is capable of storing multiple raster images. We have more interesting data structures, such as polygon sets or something like that. And so in that case, the pendulum, so to speak, swung in the direction of adding more data structures to the file format, in a way, ingraining them in the file format. But then, of course, there is a price to pay for that. Or at some point, you will ask yourself, where does this end? Are we constantly going to, people are interested yet in this new data structure and that new data structure, and by implication, should we all try to put that into the file format? I think that's unsustainable in the long run. And I mean, despite other technical considerations, I mean, parallelism, compression was supported in HDF4 already, but parallelism in particular, and I think an important, or at the time, important correction that took place was that people realized, yeah, this is a dead end, not a dead end, but it's sort of a path of diminishing returns to add all these data structures. So why not exactly back to basics or back to the roots, let's try to trim it down to a much, much smaller set of primitive building blocks that have in linguistics, you would call this productivity, meaning you have a vocabulary that's finite and you have a grammar that has finitely many rules. However, you can generate infinitely many meanings from this finite set of things. And the same thing happens with HDF5 in the sense that, yeah, we have basically 3 primitives, groups, data sets, and or array variables, and by that I mean data sets and attributes and types, and that's it. And plus the rules of what can go with what. That's the lexicon and the grammar of HDF5, and you can create infinitely many meanings from that. And so the pendulum, in a way, from that incorporating data structures at a very fundamental level, has sort of swung to the other side, where we said, well, there are good reasons maybe to not sort of chase these data structures, and whenever something else comes around, integrate that at a very deep level. And commenting on Aleksandar's observation of, is it too late? Well, I think the good news is in scientific research, and I think that's where an important role of HDF5 is, the good news is, in a way, it never stops. It's part of the research process that we create and modify the tools to conduct that research. And that's why research is different from other environments, such as enterprise and whatnot, because you better know what you are doing, because your goal is not modifying or creating your tools. You want to make a profit, you want to do something, and you just pull a solution off the shelf that you know works, and then sort of focus on efficiencies. In research, unfortunately, you have a problem that you want to solve. You don't know the answer, but in particular, you don't know which tools you will need to conduct that research. And yes, can you use existing tools to get going? Absolutely, that's what you do everywhere. But as you utilize these tools in the research process, you realize that they are not quite what you were looking for. And of course, unfortunately, there's no market, no Google, no Microsoft, no whatever the software company of the future is. There's no money in them to support research, because it's a never-ending story. And but on the flip side, or on the upside for us, this is we can evolve with that. We first of all have created something that is extremely configurable and flexible, for better or worse. This has not only advantages. Obviously, this is what this discussion about. For new users or users who want to start at a much higher level, that's a problem. But for people who are sufficiently savvy and versed in what's possible in HDF5, it is a gold mine, because yeah, you can do pretty much anything you want, and then, albeit at a seemingly glacial pace, we add new things over time. And is that perfect? Is that the right answer? No, there is no right and wrong here, in a way.
All right. Well, for Parquet, what Mark you asked, again, Parquet it has some it's a more specific tabular data format, and so in some ways he has advantages over HDF5. I would particularly say the biggest advantage is that essentially the information about the file, so that if you want, in HDF5 terms, the super block comes at the end of the Parquet file. So you could actually stream Parquet files, whereas you cannot stream HDF5 files. And so, but it's, Parquet, again, all of these newer formats have advantage of the HDF5 that they kind of were not formulated in the era of file system. HDF5 was formulated during the era of file system, and so it comes with a certain luggage or baggage, if you will, that those other file formats didn't have, and they have to, they have to solve maybe that much. But anyway, I think that this columnar approach would be fairly comparable to Parquet. I only think that if I remember correctly, there is a one, again, we're discussing how much interoperable HDF5 file content we want to create. But I think that Parquet allows basically attributes on a parts of the column. I think that's also what Parquet allows you to do. Whereas if you translate that to HDF5 attributes, that would not be possible. But again, if you break up things into, I don't want to now complicate things. But anyway, otherwise, I think it will become very, very close to the fundamental advantages that Parquet has when storing tabular data over HDF5 approach with compound data types. I mean, yesterday there was a question on HDF Forum about someone who had 400 plus columns, essentially as fields in a compound data type. And that's exactly, and they hit various problems with working with that afterwards. And the reason why, again, it was easier for them to just dump everything and have HDF5 library do the work. And so following that approach, then something like columnar table specification and some kind of HDF5 API would allow that use also for people without really making mistakes. Making decisions that then later on become more and more of a problem how to use such HDF5 files. One thing I have to remember, I just remember now, when I talk about Parquet and things, I forgot to mention that obviously, because we have HDF, the fact that we're discussing format of something in HDF5 means that yes, you could have HDF5 columnar type tables in the cloud if you use HDF. And so there was some discussion going on that my colleague John really, if he wasn't on the call, I would skip over this one. But now that he's on the call, I have to mention.
Yes, I noticed, Alexander. That basically there's an option. So the fact that you could have obviously these columnar tables as HDF5 domain in the cloud using HDF. And I'm thinking, maybe it's too late to say, but I hear that REST-vol, the unicorn connection between the HDF5 library and HDF for working in the cloud is almost there in working. So so maybe we'll get to that capability fairly soon. But anyway, so this is something to discuss. But to me, I wanted to talk about a bit more fundamental issue, and that's more how you structure HDF objects in this approach, or how you achieve this file content interoperability and various levels of file content interoperability. And anyway, with that,
I mean, I think this is a good point, Alexander. From my perspective, kind of what I've been thinking about is how much do I want HDF5 to do, but I see it as two separate things, as the file format and separately the API. So one thing I wanted to point out about Parquet is that not everyone uses the C++ implementation of Parquet. I think actually Pandas might actually have its own internal implementation in Python, right? And so for many people, Parquet is simply a file format, not an API. And I think in HDF5, we opt to conflate the two, right? You develop both the format and the API. And we often think we can only have the API with the format, and you can't separate the two because there frankly aren't that many alternative implementations of HDF5 reader other than the C library from HDF Group.
Yes.
But perhaps that needs to change, right? That this could be an alternative, that someone builds a specialized library that reads HDF5 format but doesn't necessarily use the C library for specialized use, and for some applications that actually might be more useful. So I think the thing that I actually would like to know right now about high tables, because this is already using HDF5 library, I'm not sure if it's column based, but given the BLOSK approach, I'm not sure if it matters anymore. So So actually kind of what I would like to see first from this is just a specification for what is the pi table specification top of HDF5 to begin with. And could you lay out the file format of how one would use the HDF5 file for different kinds of tables? We can get to the API a little bit later. Maybe CAPI is sufficient for some applications, but maybe we need another API specifically for tables. Maybe pi tables has already done it, but we just need to generalize this for other languages. But I think this is something I think that we need to think about a little bit. This is also happening in SAR community, right? SAR is really trying to emphasize multiple implementations, multiple libraries to access the file format, and not really pushing one implementation for everyone to use. So this is a really different approach, I think, and I think we might want to think about how that might apply to HDF5.
With ZAR, I mean, I think since you mentioned it, I think what we are really talking about is the economy of data formats and the software that reads and writes those data formats. So the ZAR model is fairly simple formulation, even simplified more by not having a file. So you get out of a lot of technical problems if you don't have to align everything into a single sequence of bytes that we call file. So they got away from that complication completely. And then they use essentially this availability of new kinds of storage that has key and value. And so a lot of other things, essentially every address of something that would be an HDF5 file, in the ZAR case, it's pre-computable. You can immediately compute by the convention what is going to be the key of that part of the content. And so there is no need for any synchronization whatsoever. As soon as you know the data HDF5 data set, and you know the chunk of that HDF5 data set, you know everything you need to know what's the key, and you just write out or read in. And so in ZAR case, yes, the format is simple, and because it's simpler, people can write more implementations of it, and therefore that they lower the economic cost of all the other things. In HDF5 case, you had this file format with all the possibilities and capabilities in, and really it was very technically and economically difficult for someone else to write the level of software of HDF5 library. And so that's, I think, in the case of HDF5, I think talking about this higher level, whatever we call convention APIs, I think makes sense, because as you point out, not a lot of people will raise their hand and write another reader and writer for HDF5 file form.
Right. I think partially for what you described, right, that there's a lot of features in HDF5, which could be both a blessing and a curse. But one thing I've discussed in the forums is how might we make it easier for someone to make some kind of implementation. And so, what I've suggested is maybe we need a sub-specification, a subset of HDF5 that does some very fundamental things that someone else could write another library to focus just on that, maybe with threading or things like this.
Yes, but again, who's going to be doing that? And is there enough, in some way, is the HDF Group as a company the right place to pick and choose which feature we like so much and which feature we don't like so much? Maybe too emotional. Maybe we need more objective crowd people that's going to say, yeah, this really lived very well. This one didn't age that well, and that kind of thing.
Well, I think, for example, big simplification would be, just create a subset that is just the newest version of all the structures, right? I think, when I was trying to go through an HDF file, the biggest thing I have to contend with is that there's like 3 or 4 versions of some data structures that I have to support, right? And maybe actually I don't care about that because I don't have data from 20 years ago. I have data from now. So, an easy subset would be, this is the HDF5 1.12 format, and I can say I can support only the newest version there, and that already would be simpler and actually more performant in many cases, because I think most people don't know that they need to say, disabled legacy support in order to get more performance from HDF5.
All good points, Mark. All good points. Unfortunately, it's very difficult to say, you know, to make a executive decision
Well,
which way to go.
I think we will never solve this problem. We have to have some fundamental definitions or principles here. Remember that HDF5 is 3 parts. It's a data model, it is API, and it's file format. And now file format becomes a little bit obsolete because with the vol capabilities, we're talking about different types of storages, and even within one file, you can introduce new storages. Let's set it apart. Now we go to the first to data model, and data model is about storing arrays of data. That's the only abstract object that you're storing in HDF5. And you use this object, you may use this object to represent other types of objects like HDF EOS did, right? Or NetCDF did, NetCDF4. And going away from this, it's a huge, it's a scope creep, right? So we have to stick to what HDF5 is. And current APIs, they essentially map array object to storage. That's what HDF5 is about. And if we want to redefine it, it's not HDF5, it's something else. If we want to stay within HDF5, then we can talk about different type of storage of this object. And currently, array is a dense array. We can talk about sparse arrays, what kind of other arrays we have, right? Otherwise, we will never, you know, solve the problem because we're redefining what HDF5 is.
I feel like the problem of being able to read HDF5 files that exist is a big one that will be around for a long time. There's a lot of HDF5 data out there, and people want to be able to read that using multi-threading and stuff like that. Also, the vol concept is not really left ECP, right? Like people really aren't creating vol connectors and
Dana, you may want to say what ECP is. People may not
the
know.
xScale computing project, right? Essentially, there's the Deos vol connector that allows you to connect to the Deos storage, but for the most part, and there's the async vol connector that allows asynchronous operations. But for the most part, like there really isn't a lot of there aren't a lot of vol connectors yet. So there's no widespread way of storing HDF5 data. And this is the same as like, I mean, we have the same problem with filters, is that people are afraid to use filters that aren't in the HDF5 library because, so how do you ensure that this filter is going to be available everywhere, right? You need some sort of ecosystem that makes it easy to deploy and build these things everywhere. And that just doesn't exist yet. But in terms of like trying to come up with a minimum set of HDF5 to, you know, to make kind of a minimal reader, I mean, sure you could, right? But oddly, I mean, it'd be easiest to target like the 1.6 file format or something that's old because those data structures are simpler.
1.2.
Yeah. Pick something really old, because if you start picking the newer stuff, you're gonna have to implement the fractal heap and have fun, right? Like that's complicated. There's a lot of stuff that's in there, and I mean, it's not. Would it be extraordinarily difficult to do? Probably not. But who has the time to sit down and architect that? I mean, it's a big. It's a large but not intractable problem. Right, the file format exists. It's specified. It's how to do that efficiently. Like that's challenging. But yeah, But if you wanted to make something that was really simple, just implement v1 B trees and local heaps and things like that, because they're quite easy to implement. They're much simpler than the data structures that came later, the extensible arrays and the fractal heaps and things like that.
Well, I don't know how long we want to go this meeting. I just want, we already went over. I just want to mention that.
I would invite everyone who is interested to HUG that will be in August and have session there to discuss. It's a good topic.
Well, I don't know if we have a call for sessions. I see only call for 15 minutes, probably 5 minutes per question. So in other words, I don't know if the sessions will be formed out of similar talks, or there will be actually session and then talks become part of the session. I don't know. I'm not saying that, but that's another issue. Anyway, I mean, I just want to say that again, I came into HDF world as a scientist. Only later in my career, I joined HDF Group. And so a lot of my thinking about the utility of HDF in my own scientific career and everything else that I did was always sort of what can I achieve and get my job done. And so, and I was not on the part where I was really obsessed with performance. So I'm not maybe, the most common driver or community that drives HDF5 library development. But I think that, again, looking at all these projects that are discussing and coming up with kind of similar structures in HDF5 file, I think that there is a certain certainty. And what I also want to say is saying, yeah, we are aware of this and eventually it'll become maybe possible. It's very difficult to plan and consider, what you're going to do, perhaps, and whether HDF5 fits your data management plans and goals. And so I think that there has to be some cheaper way and faster way to get there. And if that involves something like high-level APIs, until and when something becomes available in the core HDF5 library, I think that's maybe the way to go. Because again, as I say, I don't know how you can really successfully query a community and get some really representative answers in a meaningful amount of time to be able to really come up with some kind of quantifiable answer that has a lot of weight behind it. It has to be you have to call it at some point based on your feelings and experience and general understanding of things. Anyway, that's all I have. I really thank everyone else for talking and speaking because it saved my time and it really was more engaging. I think this is the whole point of this session, to engage people in discussion. And so last round of questions or comments, and then I think we can wrap up things.
Well, I think the last thing I'll say is just wrapping up the tables discussion is maybe we should talk to PyTables, Francesc in particular, and I think, the easiest thing might be just adopt a schema. I'm actually not sure if it's column-based or not, or perhaps approach other community members who are already have used HDF5 and bring them in, as opposed to trying to replicate their work.
No, sure. But yes, I mean, we have to speak and talk about it. To me, at least in my mind, PyTables is performance-oriented approach. Performance first, everything else second or third in terms of design goals. And so I don't think that they ever wanted to be interoperable in the level that I just talked about. To me, it's also very interesting that there is no PyTables version in the cloud. I never heard of PyTables version in the cloud, and I think because it actually used a lot of capabilities of HDF5 library and HDF5 file format, and that just doesn't map well in the cloud native computing. So, but yeah, I mean, I agree. You have to bring someone all over the table, but again, at the end of the day, someone has to make a decision where to go, and those decisions can be: we're not going to deal with this anymore, leave it as is. It's been 25 years now, another 25 years, so what? Or try to see something and see maybe that there is some natural clustering of various softwares and communities that adopt this kind of content organization. Say, yeah, we like it. It works for us. And then hopefully, eventually, when you start pulling data from various communities, which is now more and more part of scientific experience, you don't just use data from your community or from one computing system where everything is, that then you suddenly see, oh, okay, my kind of software suddenly starts working with more data without me doing anything special. But again, it's a process. It's not going to happen overnight. And so I think that's why we're always discussing, is it worthwhile doing it or just leave it as is? Because it's not going to be overnight.
Suggestion, I believe if we put on forum something that people who are interested and who work with, who want kind of column storage data, please join them. It can be webinar where people can present how they implement it and use it, and then have some discussion. Because how many use cases we know? Just HDF Group, just 1, 2. But there are more people probably there, but just at least to get the group that already uses or wants this type of storage and look at the use cases will be useful. Then document and have some kind of white paper and go from there. And this webinar can be, it can be done during this webinar, but organized on forum. So you want me to send email to forum? I can do it.
You can. It's fine.
Okay, I don't know. Mark, what do you think?
Sorry, what was that?
Are you interested in talking to other people who are interested in column storage?
Sure. I think I'm not currently working on something on that long lines, but I definitely have colleagues who are. So, and this has definitely come up internally at Genelia where I work. So, yeah, I'd be interested in engaging in that conversation.
Okay.
All right, we can work to get that figured out and scheduled. All right, thank you, Alexander. Rousing discussion. Let's see.
Who knew?
Yeah, well, you just bring them in. It'll be Scott next week, so we'll see everyone next week with Scott. Thank you.
Thank
All right,
you.
take care.
Bye.
Bye.